Alright, so we're looking at variation. There are two types of variation. One, we have direct variation, and another one, we have inverse variation. Let's start off by looking at the direct variation. In the direct variation, we are looking at two variables. Let us say y varies directly as x. Y varies directly as x. So if y varies directly as x, then what we're looking at is an idea where y is proportional to x, directly proportional to x. This is a proportional symbol. What does that mean? It simply means that if y doubles, x doubles. It also means that if y is going down by, say, 4 times, x is going down by 4 times, because they are sinking and swimming together. So they are directly proportional. If this is going up, this one goes up. If this is coming down, the other one comes down. And that's what we mean by direct proportional. Now, there is, though, within all of these variations, there is what we call the constant of variation. So there is always a constant of variation. It's represented by, I'll use a letter K. Could be any letter, right? So a lot of times we might see K being used as the constant of the variation. So within the two variables going up and down together, there is a constant value that doesn't change. How do we represent this, though, like a formula? How are they related together in an equation? Well, this is how they're related together in an equation. Y varies directly as x is y is equal to k times x. So while the y and the x are changing their values, the k will remain constant, because that's what it is. It's a constant of the variation. And because of this idea, we are able to use that to solve problems. Let's look at a very simple problem surrounding this idea. All right. And we have a case, and m is equal to 2 when v is equal to 3. So they want us to find, m when v equal to 6. So this is the problem that we're about to solve. But these are the cases. What I could say to us is that in these variation questions, they will always have to give us something that works. For example, here, that happened already, and we'll be able to use this to find the constant, and then use the constant to solve the problem. Let's write the formula that will be running for this math. It says m varies directly as v squared. This means that m is equal to k times v squared. Now, with this case, what we're going to do, as you can see, we're going to substitute m equal to 2 for m and 3 for v, and then find the constant. So m is 2. All right, so we have m is 2, and then we have times. So m, which is 2, is equal to k times v squared, which is that. So we're looking at 2 is equal to k times 9. So k is equal to 9 over 2. So we have a value for k. Now, because we have a value for k, this is the constant, and it will not change. So while m becomes something else and v becomes something else, this will remain constant. So let us see now how we'd use that. So now that we know that k is 2, 9, and we also know that m, we don't know what that is yet, but v is equal to 6. We can use the same formula for this case, where m is equal to k times v squared. Substitute. So m is what we want to find, but k is 2, 9 times v, which is 6 squared. So if we go further, we're looking at 2 over 9 times 36 over 1. And of course, 9 into the 1 times, and 9 into the 4. So m is equal to 8. So there it is. Just a simple way of introducing the direct variation question. It's very simple. Is equal to m is equal to k and stuff like that. All right. I hope you enjoy watching that.